Okay, hello, welcome back. Here we are again in Godot. Yeah. All right. So as always, today the link to the video that I'm following along to can be found in the description. The name of the YouTuber is HeartBeast, HeartBeast, one word. I'm not going to show his website this time. I'm just going to try and jump straight into it from where we left off, which was when we last were here. We managed to basically create this little thing that we've done. Imported some of our own. Not our own, but imported some sprites, animated sprites, applied the animated sprites, and obviously imported some graphics for the platform, and did the required coding to ensure that the right sprites are playing when we play the game. This was the code. Here, we didn't really add that much code. I mean, we just added these here, really. We added like 4 lines of code. Well, 5. But, 4 or 5 lines of code is all we added to actually get the sprites to work. 1, 2, 3, 4, 5, 6, 7. 7 lines of code. Which wasn't a lot at all. Really. All right, so let's just jump straight back into it, guys. I'm not gonna talk too much. So the next is part 3 of his platformer game tutorial, and it's called Smooth Character Movement. Like I said, you can find a link in the description if you would like to follow along. And hopefully you guys can't hear him. You shouldn't be able to hear him anyway. I'll just double check that you can't hear him. Yeah, that's fine. Okay. So basically what we're going to be doing today is just working on the animation to make it look a little bit more organic, smooth it out, and add a falling sprite. And he's just reiterating, try not to change the scaling when adding collision boxes, just change the extents, not the scale, when you're doing the collision boxes. So you want to keep that 1-to-1 really, wherever possible, and change the extents to fit. Otherwise it can go faulty. Apparently a lot of people are reporting problems. So if you are having issues, if you're following me for some reason, which I thank you for, but and you're having problems with your collision boxes, check that your scaling is 1-to-1 and that it's your extents that you want to be resizing. Oh, okay. Let me just show you that. So on the debug window here, view collision shapes. If you turn that on, when you, which is this like blue box here, when you run your game, it shows them in game as well. There you go. So you can see your collision boxes for debugging purposes. I don't need that on though. So there you go. Hey Surliger, Rob makes Mario. No, Rob perfects Mario. Alright, so just changing a couple of things here. Right. Okay. So basically what we're doing here is we're adding an acceleration of 50. So this is a variable, constant acceleration equals 50 pixels per frame. So that's just a variable. That means nothing else. We were just assigning the variable called acceleration to 50, which equals 50 pixels per frame, because we're using it with motion. So this, when moving to the right, then we're setting our acceleration to, instead of speed, whereas before it was speed of 200, it was automatically a speed of 200. What this is doing is saying the first frame your speed will be 50 pixels per frame. The second frame it will be 100 pixels per frame. The third frame it will be 150, and the fourth frame it will be 200. But it'll continue, so then it'll be 250. So our max speed will actually be the number of frames we move times 50. So if we were to run that now, you'll see that the character will run off the screen really quickly. There, see? It just goes. You can see the acceleration kicks in, but he runs really quickly. Oh, see, and then I missed him. So that's what that's doing. It's basically increasing the speed by 50 pixels per frame as we hold down the button. So what we're going to have to do is then maximize it, put in some code so that it doesn't run any faster than 200. So 200 pixels per frame becomes his maximum speed. So that's what we're going to have to set in soon. next, and obviously this is going minus because we're going to be going left. So looks like the Flash. Okay. All right. So we're introducing a new function here called min. So motion.x at this point equals acceleration. Depending on the frame, acceleration could be a factor of 50 up to whatever. So what we are saying here is after this is calculated, so this could be 250 because we're into the 5th frame. What we're saying here is motion x equals, so in other words, we want to change the value of motion x to either motion x, so it equals what it is, or we want to change it to max speed, which is we've set up here at 200. So min means whichever the minimum number is. So it'll look at motion x, what it currently is, and if it is less than 200, then motion x equals motion x. However, if motion x is greater than 200, so max speed is 200, then it sets motion x to 200 and keeps it at 200. For as long as you've got that button pressed, motion x acceleration will always increase by a factor of 50, but then will reset back to 200 on the next line. So it will be like as each frame is running, it will be 200 here, so that will be fine. Next frame it'll be 250, but as soon as it hits the next line and it sees that motion x is actually set to 250, it will instantly change it back to 200. So when it comes back through here again, motion x will become 250 again, but then it will check again what motion x speed is. Is it less than max speed? No, then motion x equals max speed 200. So that way you'll always get your you'll always keep a maximum speed of 200 there. It's basically using an if statement but built into this function. So min means minimum, so it wants you, this equals whatever the minimum is, whatever the lower number is between these two variables. And I suspect we're going to do the same here. But it's just going to be identical because max speed is going to be, acceleration is going to be minus. So minimum don't necessarily work with a minus number. So let's just see what he says. It might be a max. Ah, right. Okay. So yeah, it makes sense. We don't actually need this line anymore as a result of this function, so we can get rid of that. And what we can do here is actually just put in the plus acceleration directly into here. So we do the math. It does the maths in here. So whereas before we had this being calculated on a separate line above it, now it's doing it within the function. So motion x equals motion x, which could be 0 when before you've pressed it. Once you press it, the first frame, it becomes 50. So motion x plus acceleration, which with set acceleration is 50. So motion x becomes 50. The second frame 100, the third frame 150, the fourth frame 200, the fifth frame it will be on 250, which means it will be higher than max speed. So the value of motion x is max speed, which is 200. So there we go. I'm still trying to figure out how he's going to do it from to the left though, with minus numbers. Right, okay. So he is using a max function. So this is max. Okay. So yeah, that makes sense that there would be a max, because obviously minus 200 is a greater number than minus 500, minus 250. So minus max speed is minus 200. And that would be a acceleration there. Is that right? Have I done that right? Motion x equal max motion dot x minus acceleration. Yeah, because if you're standing at a still, motion x is 0. If you move to the left, then you're moving 50 pixels, negative 50 pixels. So then it becomes minus 50, which is lower than minus 200, minus 100, which is lower than minus 200, minus 150, which is still lower than 200, minus 200. And then on the fifth frame, it would be minus 250. So we want to limit it to minus 200. So therefore, it will always be minus 200 until we stop pressing the button, and then at such stage motion x equals 0. But I suspect this will be motion x equals motion x minus acceleration. At some point, to give it a bit of a slide. So let's do a Control S. Let's run that, because it'll still there is a slight acceleration there. It's very hard to see, but it does stop suddenly. If I was to change acceleration to 10, so it's a lot slower, and run it, you should see it difference. Or even change it to 2. Yeah, you see, yeah, you can see it is really, so it does work. It's very hard to pick up because it's only 4 frames, so it's like 4,000th of a second or something like that. No, not 4,000, 60 frames per second. Alright, he's introducing another function now called lerp. This is like a lerp interpretation. And the way lerp means is, so the value that's going to be returned is, it's asking us what our initial value is, and so our initial value is whatever motion x is. Motion x being this, the speed that the character is currently moving at, probably 200. Probably most definitely 200 if you're moving from left to right. What we are attempting to get to, which is going to be 0, because that's how fast we want to be going when we come to a stop. We want it to be 0, and then it's saying, well, how quickly do you want to get from yours to a dead stop? So from 200 to 0, how quickly? And that number should be a number between 0 and 1. It's like basically a percentage. So it wants, so we're going to add a 0.2, so we're going to reduce it at 20% per frame. So yeah, I think that is pretty much what that means. So from, to, and how much to reduce. So 200 to get to 0, 20%. I think that's what that means. So he should do a little slide when he's running. Yeah, you see the little slide? He just does, I think it's like a couple of frames before he comes to a complete stop. So that's basically what that's doing. He's just adding an automatic deceleration as you wish. But it doesn't necessarily work. I mean, it still works for jumping, but not as well, if at all. Sorry, I'm losing it. So we're adding a friction variable. It looks like it's a boolean which equals false, which means it's not on. Friction equal true. So what? That's when he's standing still. Friction equals true. Sorry, I'm sure it'll come to me in a minute what he's doing here, but. Alright. Right, so when he's idle, he's supposed to be on the floor, so friction is true. He's on the floor. He's touching the floor, so he has friction. So that's what that means. So if he's idle, he's touching the floor, friction has to be true. And then we're putting in if friction equals true, so he's not moving, friction is true because he's idle. So if he's on the floor and friction equals true, he's deleted that. Right. So it's basically saying if he's on the floor, if he's touching the floor, friction is 0.2 on this code here. Okay. If he's not in the air, if he's in the air, so if he's not touching the ground, then we're setting friction to be 0.05. Right, okay, I think I've got that out. So instead of putting the else statement here, the if statement here, which is what we had before, the loop motion here, basically we're putting it, we're doing it under whether or not he's on the floor. So it's saying if it's on the floor, if he's touching the floor, then yes, decelerate at this speed of 0.2 friction, if friction equals true, because friction does equal true. It should do. Then friction speed is this. However, if he's not touching the floor, then our loop friction speed is this. That's how I'm interpreting that anyway. Right, so the end result is when we're running left to right, we're slowing down fairly quickly, but when we jump, our friction fall rate is less. not that it's very hard to see. Alright, okay. I don't see what the point is for doing it for this particular, but hey Jack. You're heading into the army. Well, good luck with that. Yeah, I'm messing around with a game engine called Godot, which is an open source game engine. Right, okay, so we're moving on now. We're adding a new animation called Fall. And let me make sure we keep the same. And sprites, player, and we're adding jump 3 into it. Here we go again, with it being blurry. That's that import preset, 2D pixel re-import. Now add jump 3. Ah, crap. Check if that's right. All right, so remember this is like, all right, the character's not on the floor, so we're going to now play the jump sprite. So we're changing the sprite so it looks like he's jumping. So the first thing it's doing is if motion is less than 0, then play jump. Now remember, if you're moving upwards on the y-axis, you're heading from a negative to 0, or sorry, up is positive, down is negative. No, down is positive, up is negative. So if you're moving in an upward motion, you're going to be moving, it's going to be a negative number. So if it's less than 0, then it means you're moving upwards. So if motion along the y-axis is a negative number, it means you're actually moving upwards. Therefore, you want the sprite that shows you jumping up. Else, your Y motion is actually going to be greater than 0, because coming down the screen it actually increases, not decreases as you would think. It's reversed. So as it's falling, you want it to play the fall animation, and those are the ones that we. So this is the fall animation, this is the jump animation. So it's telling you, or sprite, so it's telling you which one it wants you to play. So if we just save that and play it, oh no, yeah, it should work now. Alright, so if we jump up, and then it changes when it starts coming back down. There we go. Yeah, I keep forgetting you need to put the colon in at the end of the if statement or at the end of the else. It doesn't require a colon at the end. Okay, we're going to be doing some drawing here using our old tile maps. Doesn't really work because they haven't really put in a like a corner bit, have they? So it doesn't really look that good there. Need a sprite which you haven't got for that corner bit. We haven't actually got one. I'll just do it that way, doesn't matter. And he wants another one. Move him over here. Okay. Save that. Run it. reach that one. It's work. I mean, that's what we want. Right, okay. So what's going on here is, remember, like in old games, you used to be able to float like that because of the way the collision box was set up. And so this is as a result. He's not falling off, even though he's not on the edge. He's still considered to be on the object because of the collision box. So if we were to go into, it's probably easier if we go into visible collision shapes and then run it. Oh, I turned his off, didn't I? Hang on, let me turn his back on and run it. All right. So yeah, you can see where the collision box is, but the character itself looks like it's, you know, it's the character itself looks like it's not touching it, but the collision box is actually touching it. You can see it there. So he's floating in space in essence until he moves far enough that he's no longer touching it. So what he suggested, so that was like an old style gaming, when, you know, platform games, that used to be the thing. That used to be what all sort of platform games used to suffer from that. But now our collision shape doesn't have to be square or rectangle anymore. We can actually set a capsule shape instead. I'll just zoom in for this. So this is a capsule state here, and so if we set a capsule, I just got to figure out there we go. Right. So if we set a capsule shape instead of a rectangle shape, and then if we click on here, we can then set the radius and height, radius being horizontal in this case, So we still want it to be 14, and we still want the height to be 28, so that it incorporates. So our collision shape is completely different now. It's not a square. So I think that's all you need to do. And so if we run that now, he falls off. You see? You can't get him to, he gets close to the edge, he falls off. So no more floating. There you go, slides off. So that's how you solve that issue. Alright, okay. Well, that was the end of that video actually, so that we got through that really quickly compared to how long we've taken in the past. Less than an hour. There we go. So there we go. So we looked at that to prevent it from floating. It just keeps sliding off. That's pretty cool. So I said that's changing collision shape to capsule in there. Okay, well I'm gonna end this stream there, and I'll possibly do one more stream of Godot a little bit later on. I'm going to take a break and spend some time with Sue, and then we'll do another Godot video maybe a little bit later on, and then maybe later on tonight I might do Outward. I don't know. We'll see how I feel with Outward later tonight. I may or may not do it. But again, thanks for watching, and I'll catch you all later, I hope. Until then, bye-bye.